Alright, so in this video, we're going to go back to 3.2, or solving linear equations algebraically, and we're going to specifically look at word problems and kind of creating our own systems to be able to solve. We're going to look at only one problem in this video, and I'm going to show you how you could solve it using substitution or elimination. So first we're going to start with solving by substitution. So this problem states, you are the manager of Fiona's in Willoughby. You purchase your decaf and regular coffee beans from a local supplier at the West Side Market. Decaf costs $6.50 per pound and regular costs $8.75 per pound. Last week, you ordered 41 total pounds of coffee beans and your purchase came out to total $327.25. So this question is asking, how many pounds of each type of coffee did you purchase? Given the information that we have, we're going to be able to set up two equations and figure out how many pounds of regular and how many pounds of decaf you purchased. Regardless of whether this is using substitution or elimination, you're going to set up your equations the same way. So we want to make two equations, one relating to cost and the other one relating to quantity. What I mean by that is we want to make an equation dealing with how much everything cost and what our total cost was. The other equation dealing with just the total amount of pounds or whatever other unit that you're finding. So for the first equation for cost, I know that decaf is $6.50 per pound. I don't know how many pounds I bought, so that's my first unknown. I'm going to say D plus, same thing for the regular coffee, 8.75. I don't know how many pounds of regular. That's a different unknown, so I'm going to make a different variable. R equals my total cost, which was $327.25. So that's good for our first equation. For our second equation for quantity, we know that we had 41 total pounds of coffee. We don't know how much of either. So for this equation, I'm just going to put decaf plus regular equals 41. Again, since our unknowns are the pounds of each, and the pounds of each should sum up to 41. So if I'm solving by substitution, what I want to do is get a variable by itself and plug it back into the other one. So while you could do this for either cost or quantity, the quantity equation is going to be a lot easier to work with since there's no coefficients. For either D or R, in one step I can get that variable by itself and not have any ugly fractions or decimals to deal with. So I'm going to go ahead and get D by itself. It doesn't matter which one you use. So now I have my equation D equals 41 minus R. So now what I'm going to do is wherever I see a D in that top equation, I'm going to plug it in for what I just found. So I'm going to now put down 6.5, 41 minus R, plus 8.75 R equals $327.25. So again, even though this looks ugly, we only have one variable now in this equation, so we're good to go. We can now find what R is numerically. So first I'm going to distribute. That's going to give me minus 6.5 R plus 8.75 R equals 327.25. From here, I want to combine like terms, so I'm going to combine the R's and I'm going to combine the numbers. The negative 6.5 and 8.75 combine to give me 2.25 R. I'm also going to subtract the 266 on both sides. And that's going to give me 60.75. My last step from here is going to be to divide both sides by 2.25. And I'm left with R equals 27. So that was a lot of work, but the nice thing with these kinds of problems is that after you find the one variable, you're basically in the home stretch. So what I'm going to do after I find R is I'm going to plug it into either the cost or quantity equation to find out what my other variable was. Now, while you can plug these into either equation, it's going to be a lot easier for you to plug it into the simpler equation. So if I plug this into the quantity equation, I can in one step figure out what D is. So now my equation is going to say D plus 27 equals 41. I'm going to subtract both sides by 27. And I'll get D equals 14. So what I found in this problem is that given that information, I had to do about 27 pounds of regular coffee and 14 pounds of decaf. Now we're going to look at the same problem, but I'm just going to show you how you would do it using elimination. So again, we have the same problem. You're buying decaf and regular. Cost comes out to be the same thing. Similar to substitution, regardless of what method you end up using, you're going to make your equations the same way. But now, after we've set up our equations, how this is going to differ is where I'm going to go from this step. So before in substitution, I got a variable by itself and I plugged it back in. But here, in elimination, what I want to do is I want to manipulate these equations to get something to match up so that I can eliminate a variable entirely. So I can see here, since the quantity ones, the coefficient in front of the D and R is right now a 1, I can multiply just the bottom equation to get these to match up to the top equation. What I'm going to do in this problem is I'm going to match up the D's. So what that means is I'm going to multiply the entire equation by 6.5. So the D, the R, and the 41 by 6.5. When I do that, my new equation is going to look something like this. So because I did that, now the D's match up. They're the same sign, so I'm going to subtract. They cancel. I'm going to get 8.75 minus 6.5 is 2.25R. And then on the other side, I'm going to get 60.75. Divide both sides by 2.25. And same thing. We're going to get that regular is 27 pounds, meaning that I had to get 14 pounds of decaf. So what we're going to work on in class, you're going to try both methods, but what I want you to take away from this is that it doesn't matter which method you choose. Whatever one kind of works best for you, either one will get you to the same result if you do all the steps right.